Today we're going to talk about areas of parallelograms, triangles, and rhombuses, okay? Now, a lot of you already know the formula for these. What's the formula for area of a parallelogram? Everybody? Base times height. What is the formula for triangle, area of a triangle? Half times base times. What's the formula for the rhombuses? Well, rhombus, what's a rhombus? It's a parallelogram, isn't it? So hold on. So rhombus is a parallelogram also, so it's base times height also. So if they give you a base and height, that's what you will use. But they're going to give you something else. So yeah, they're going to give you diagonal. So if they give you a base and height, that's easy, just to multiply base times height. But if they give you diagonals, we'll show you what the area of a rhombus is. Okay. Does anybody already know what it is? Okay, we'll get there. Let's not. Okay, so here we go. First, we're going to talk about area of a parallelogram. Okay, here we go. Of course, these are theorems, so we're going to prove them. Okay, so the area of a parallelogram, as you said, equals the product of a base and the height to that base. And this is important that they say height to that base, because you know if you have a parallelogram, any side could be the base, right? So if you chose a base, we're talking about the height up to that base. Okay, so there you go. And here's a picture, and as you can see, this picture kind of gives you a hint as to how you could prove that the two, how you could prove that the parallelogram, the area of a parallelogram is the base times height. Okay, so write that down. I'll wait for you. Okay. So notice the auxiliary lines that they drew. Okay. Anybody see what we could do to find the area of a parallelogram? By the way, let's review a little bit. What have we found so far? We learned that the area of a what first? Triangle. No, last time we learned the area of a square first. Very good. We found that the area of a square is side square, right? And then from there, that was a postulate. We actually proved how to find the area of a rectangle. And what was it? It was base times height. Wait a minute. How come this is same as the rectangle, base times height? Yeah, basically you get a rectangle. Why? Okay, so somebody, how about somebody explain? Tony, what do you think?
Base times height, because if you actually extend the sides of a parallelogram, you can see from a rectangle.
Yeah, you basically get a rectangle if you were to extend this side over here and then draw the altitude here, right? And so what?
And then if you draw the rectangle, you could cut it also at the, like in the diagram, you could draw the something like PV and then the two right triangles.
Yeah, you get two right triangles right here. Like I could draw another altitude here and here. And so guess what? These two triangles are congruent. Okay, thank you. These two triangles are congruent, right? And of course, it looks like they're congruent, but guess what? We have to prove it, right? Because if they are congruent, guess what? We could use some of the postulates we learned. First one was what? Area congruence postulate, where if the two figures are congruent, what do you know about their area? They're same. And we also learned about area addition postulate. We could add areas into together and so forth. So if the two triangles are congruent, we're done, because basically if I could, if these two triangles are congruent, you're basically finding the area of the rectangle. Does that make sense? So are these two triangles congruent? Yes. Yes, they are. How come? Why are these two congruent? Why are these two triangles congruent? I want you to think about this as a group. Go ahead. There were two ways to think about it. Two ways to do this. So good. A lot of you got it already. How about Chris? What did your group come up with? Why are these two triangles congruent? Okay, let me give you a hint, Chris. The two triangles are what kind of triangles? These two are right triangles. And Chris, what do you notice about opposite sides of a parallelogram? They are congruent. So we know that SP and RQ are congruent, right, Chris? And so also, Chris, what do you know about the heights of these parallelogram or rectangle? Thank you. They're congruent, right? So we know that the heights are congruent, right? The altitudes, the length of the altitudes are congruent, and then SP and RQ are congruent, and they're right triangles. But guess what? By I haven't asked you guys. Chris, what do you think? By HL, the two triangles are congruent, right? There's another way of thinking about this. So Chris is correct. By HL, the two triangles are congruent. There's another way Did anybody come up with a different way of proving that the two triangles are congruent? One person? Okay, Tony, what did you come up with? Oh, two. Okay, Tony, what do you think? Two people. Yeah. You could either use HL or you could use. Not quite. What'd you say? Angle side is correct. So it says right here, we know that the area 1 is equal to area 3, right? By area congruence postulate. I mean area congruence postulate, yeah. And so we know by HL that they're congruent. But how do they say? Why do we get angle side? Okay, discuss with your group. I'll wait. Go ahead. It's a nice review. Go ahead, everybody. All right. What did your group come up with? Pomon, what did your group come up with?
I'm not sure.
Okay, let me give you a hint. Pomon, we know that
VSP and TRQ.
yes, VSP and TRQ are congruent. Why?
Because they're corresponding.
Yeah, because you have two parallel lines. SP and RQ, aren't they parallel?
Yeah.
Because you have a parallelogram, right? And isn't it cut by a transversal ST right here? So look, VSP and TRQ are corresponding angles of two parallel lines cut by a transversal. So by angle side, because we know they're both 90, right? Right? So we know that they are congruent. So as you can see, listen, to prove this, look, we know that area 1 and area 3 are equal, correct? We just showed that because the two triangles are congruent. So therefore, we know then the area of this whole parallelogram is equal to area 1 plus 2. But what's area 1 equal to? Area 3. Therefore, if you add area 2 plus area 3, you get a rectangle, and we know how to find the area of a rectangle, which is base times height. Okay, any question?
No.
Okay, good. Let's move on to the next theorem. Okay, so that's a good question. Somebody said, why are the heights congruent? And the answer is because yesterday we learned what? Height of the rectangle or parallelograms are what? Congruent of the same base. Well, it's actually, yeah, it's the definition of the height. You're right. So it's not really the theorem or anything. But we did learn this yesterday, right? Thank you for correcting. Correct. Let's move on to the next example then. I mean, theorem. Here we go. As you said before, the area of a triangle is base times height divided by 2, or half times base times height. And here's the theorem. The area of a triangle equals to half of the product of the base and the height to that base. Again, they're being careful that it's the height to that base that we're talking about. So it's half the product of the base and the height to that base. And here's a picture. And as you see, this picture shows us why this theorem works. Okay, we could actually prove this. Okay, so as you write this down, think about how you go about proving that the area of a triangle equals to half the product of the base and the height to that base. Okay, go ahead, everybody try. So take a look at this. How would you go about proving that the area of a triangle is half the product of the base and the height to that base? Of course, again, hint is that they drew these auxiliary lines, right? How do you think they drew X, W, and WZ? Because if you know how they drew that, it's pretty straightforward. How about Jet? What do you think?
You have to prove that XYZ is congruent to WZX.
Correct. If I could show that these two triangles, yeah, one in yellow, that's what we're talking about, and the other one, X, W, Z, if those two triangles are congruent, we're done. Because if they are, then it's half of the whole thing. And the whole thing is a parallelogram. Very good. So what is this X? How do they draw this auxiliary line XW? How about Samantha? Parallel to ZY, because you know that the point outside our line, there's exactly one line that's parallel to it, right? And what do you think they did with WZ? Yes, parallel to XY, same thing, right? So we basically have a parallelogram, and we just learned how to find the area of a parallelogram, isn't that right? So all we have to do then is show that the two triangles are congruent. It's a nice review, isn't it? Okay, go ahead. How do you then show that the two triangles are congruent? Okay, I'll give you time. Go ahead. Think about it. How do we know that the two triangles are congruent? So as you can see, that if I could show that the two triangles are congruent after drawing these two parallel, right, sides, you have a parallelogram. Why are these two triangles congruent? How about Justin? What did you group come up with? Okay, let me give you a hint, Justin. What do you know about parallelogram? The opposite sides of parallelogram, Justin. They're congruent. So guess what? X, Y, and W, Z are congruent, right, Justin? Okay, so some of you saw the answer. Okay, and then X, W, and Y, Z, they're congruent, right? Well, aren't they sharing the same side, Justin? So guess what? By side, the two triangles are congruent. Isn't that right? Yeah. The opposite sides are congruent, right? And then they're sharing the same side, X, Z. Correct? Are we good? There's another way of doing this. Jet, what's another way of showing that the two triangles are congruent? Angle, side, angle. Okay, how would you do that?
You would find parallel lines that by triangles.
Uh-huh.
And
Sure. So you know that XZ and YZ, they're parallel. You got a transversal XZ. So you know that the alternating angles, this angle right here and those two, okay, are congruent. So that's one angle. What are the angles are congruent?
you can also say that equal XCW and ZXY are congruent with this. You can also do it the other way.
Yeah, so you use these two parallel lines, right? There's a transversal XZ, and then you could say this angle, those two are congruent, so they share the same side. Side angle side works. I mean, angle side angle works. Turns out side angle side also works. How would you do that one? Nicole, this is a nice review. Yeah, angle Y and W are congruent because what do you know about the? Yeah, opposite angles of the parallelograms are congruent. So you know that Y and W are congruent. So well, we also know the opposite sides of the parallelograms are congruent. So side angle side also works. So all these things work. Okay. All right. So that's good. Yes.
Can't you basically also use the definition of grid triangles also?
Yes. I mean, of course. Yeah. If you could do any one of those three, right? All right. So you know then that the two triangles are congruent, of course. Therefore, that's why it's half of it, right? So two triangles are congruent. Well, one of the triangle must be half of the whole parallelogram because you have the two triangles congruent. Therefore, half of the base times height gives you the area of the triangle. Easy enough? Okay, very good. Okay, so the last term of the day is, of course, about the rhombus. Now, if you know the base and height of the rhombus, since rhombus is a parallelogram, you could just find the area by base times height. But like I said, what if they only give you diagonals? Well, it turns out it is simply the product of the diagonal divided by 2 is the area of the rhombus. Isn't that interesting? So here it is. The area of a rhombus equals to half the product of its diagonals. Does this mean half times diagonal 1 times half times diagonal 2? No, that's not what it means. You don't. Some of you are thinking distributing. Do I distribute half here? No. When do you distribute? If there, not only when there's I could put parentheses here around D1 and yes, when you have more than one term, right? If this was D1 in parentheses D1 plus D2, then that's when you distribute. Don't do that. That's not what it's saying. It's basically saying you multiply the two diagonals together and divide it by 2. Does this make sense? Here you're just multiplying 3 things here. You don't distribute. It's monomial, right? So therefore, you don't distribute half. There's only one term, right? You only distribute if there's more than one term that the number is multiplied. So, right? Does this make sense? So why does this work? That's the question then. So they, by the way, what do we know about diagonals of rhombus? It's really nice because it does many things. Josh, they're perpendicular first of all. That's nice. Secondly, what else is, yes, point one. They bisect the angles there too. Yes. What other thing do we need? Yes. They bisect each other. Turns out we need to know that they bisect each other and they're perpendicular. Those things going to help us. Okay, go ahead. That's what's going to help us. Go ahead. Everybody think about why this is true. I'll wait. Good. So let me ask you this. This is important. If my diagonals are 4 and 6. Okay, 4 and 6. What is the area of this rhombus? 4 times 6. What's 4 times 6? Divided by 2, which is? Okay, you know how to do that, right? You don't distribute that half. Some of you keep on saying, do I distribute that half to both of the diagonals? No. Okay, then you get it wrong. Now, why does this work? By the way, would this work for a parallelogram? No. It only works for a diagonal. I mean, rhombus. Would it work for a square?
Yes.
Yes, it will. Because square is a rhombus, right? It's a special type. Now, how would you go about proving this? Anybody have any idea? Can I give you a hint?
Yeah.
Okay, here we go. Watch this. So you see how we have a rhombus like this? Let me just, what do you see here? What kind of triangle is this? Okay. Yeah, actually, yeah, you don't need to know the size, but it's a triangle, right? Do you know how to find the area of a triangle? We just proved it, right? And how many of these triangles do we have? Two of these. And are these two triangles congruent? Yeah, you can see it by angle, by side, they're congruent, right? So we have two of these same triangles. Well, if I find the area of one triangle, you just have to multiply that by 2. How do we find the area of this triangle? How about, because all we need to do is multiply that by 2 because those two triangles are congruent. How about, Eamon, how do I find the area of this triangle here, the yellow triangle? Well, by the way, tell me the formula for it first. It's half times base times height. So it's half times, what's my base in this triangle? Which one? What's the height? What's the base of this yellow triangle? D1. Okay, D1. What about the height? Half of D2. It's half of D2 because we know that the diagonals of rhombus bisect each other. You guys remember that? All right. So if that's true, what is the answer here? We get 1/4 of D1 D2, right? Wait a minute. That's not what we wanted. Why do we get 1/4 of it? Yeah, there are 2 of them. Guess what you have to do? Multiply by 2, right? Does that make sense? When you do, because we're not talking about just half of this triangle, we're talking about this whole thing, which is a rhombus. What do you get?
1/2 of D1 D2.
Okay, that's the reason why this works, okay? Any questions?
1/2 of 2 D1 to D2.
Guys, do we distribute this 2 here? You only distribute if you have more than one term inside. I'm just multiplying 4 things together, right? How do you multiply 4 things? Or you multiply 2 at a time, right? Do you distribute this 2 to this? No, please be careful. Does this make sense? All right, good. Can you do something like this for your homework tonight? Okay, good.